guess I'm just a play date to you.
Wake up in your bedroom and there's no
Hello, I'm Adriana Binti Zamri. Today I will explain about key concept problem. First key concept is motion problem. An object can be called motion when it shows the position change with the time which is acceleration and velocity. Acceleration can be known whether the object is moving speed up or slow down. If the value is positive, the object is moving speed up, but if it is negative value, it moving slow down. Velocity involves a movement, whether forward or backward, that can be determined according to the value of the velocity function. If the value is positive, the movement is forward. If the value is negative, the movement is backward. We can find the value of displacement by integrating the velocity function. Displacement is the shortest distance from the starting until the final position. Velocity is using the determined integral will give us the displacement of moving object, while speed is using the determined integral will give us the total distance. That's all, thank you.
Hello, so here we are going to discuss about method. In order to tackle the concept problems, we need to apply integration. By integrating acceleration equation, we will get velocity time equation, which is our first equation of motion. And we can find velocity. Next, if we want to find position of an object, we can reverse the first equation. This gives us the position time equation known as the second equation of motion. When the acceleration is constant, by integration, we will get our third equation of motion. These three equations can be used to calculate velocity, acceleration, and find position.
So next, we'll go to examples and analysis. Example 1. If the acceleration of an object is given by I plus 2j plus 6tk, find the object's velocity and position functions given that the initial velocity is j minus k and the initial position is I minus 2j plus 3k. We'll first get to the velocity. To do this, we need to integrate the acceleration. So, from the question given, we have the value of a. So, we substitute the value into this and we integrate I plus 2j plus 6tk with respect to t. So, using basic integration skills, we'll get the answer of ti plus 2tj plus 3t squared k plus c. To completely get the velocity, we will need to determine the constant of integration. So we can use the initial velocity to get this. So we know the initial velocity means velocity is 0. So from this equation, we put the value of 0 into t, then we'll get this. Here it will be 0, here will be 0, here will be 0. So 0 plus 0 plus 0 plus c, we'll get c. So we know that here from the equation, from the question, v0 equals to j minus k and v0 is also equals to c. We can substitute this j minus k into this equation. So this will help us to get this, the initial velocity, where the answer will be ti plus 2tj plus 3t squared k plus j minus k, and we rearrange them. We'll get ti plus 2t plus 1j plus 3t squared minus 1k. Next, we will find the position function by integrating the velocity function. So we get the value of velocity just now, so we'll put the value of velocity into this equation. So we integrate ti plus 2t plus 1j plus 3t squared minus 1k with respect to t. So we'll get the answer of 1 over 2 t squared I plus t squared plus tj plus t cubed minus tk plus c. So using the initial position that the equation provides us, we know that the initial position where r equals to 0 is I minus 2j plus 3k. So the other value is when we put the 0 into this equation, whereby all the t will be replaced with 0. So we know this will be 0, here will be 0, here also will be 0. So the value left is c. So we substitute this value into c from the function. So we know that the position function is 1 over 2t squared plus 1 I plus t squared plus t minus 2j plus t cubed minus t plus 3k. Next, we'll go to the second example. An object acceleration is given by 3ti minus 4e to the power of negative tj plus 12t squared k. The object's initial velocity is j minus 3k and the object's initial position is negative 5i plus 2j minus 3k. So determine the object velocity and position function. To determine the velocity function, all we need to do is integrate the acceleration function. Given the acceleration function in the question, substitute the value of acceleration and we integrate it with respect to t. Therefore, we'll get the answer of 3 over 2t squared I plus 4e to the power of negative tj plus 4t cubed k plus c. don't forget the constant of integration, which in this case is actually the vector of c equal to c1i plus c2j plus c3k. To determine the constant of integration, all we need is to use the value of initial velocity that were given in the problem statement. We knew that the initial velocity whereby the time is 0, so we can substitute the value of 0 into t from this equation, and we get the answer of 4j plus c. We knew that c is equal to c1i plus c2j plus c3k, the constant value. We substitute into this equation. Therefore, the initial velocity have two values, which is j minus 3k from the question, and the value of this when we substitute 0 into this equation. We'll get 4j plus c1i plus c2j plus c3k. To determine the values of c1, c2, and c3, all we need to do is set the various components equal, or in other words, compare from both sides. For the value of I, the left hand side, there is no value, so it will be 0 equals to the value of I from the right hand side is c1. We do all the same thing for j and k. So from the left hand side, there is a value of 1. And from the right hand side, there is a value of 4j and c2j. For the value of k, there is a negative 3 on the left side, and there is a c3 on the right side. Therefore, we can conclude that c1 is equal to 0, c2 is equal to negative 3, whereby 1 minus 4, c3 is equal to negative 3. Thus, we knew the velocity will be 3 over 2 t squared I plus 4e to the power of negative t minus 3j plus 4t cubed minus 3k. The position function is simply the integral of the velocity function we found in the previous step. Therefore, we replace the value of velocity when we integrate it with respect to t. We'll get the answer of 1 over 2 t cubed I plus negative 4e to the power of negative t minus 3tj plus t to the power of 4 minus 3tk plus c. We use the value of initial velocity from the problem statement to determine the value of constant of integration. The initial position, we knew that the t will be at 0, so we replace the value of t here with 0. Note that, and there is a power that is to the power of 0, the answer will be 1. Therefore, we will get, for this, when we replace t equal to 0, we'll get negative 4j plus c. Note that the c is just as the same as the previous step, where c equal to c1i plus c2j plus c3k, and we substitute the value of c into this, we get the answer of negative 4j plus c1i plus c2j plus c3k. The value of this is from the question given. Therefore, we can compare both sides into this. And we repeat the same step as the previous. To find the initial velocity, we do the same thing to finding the initial position, where we compare the value of I, j, k from the right hand side to the left hand side. And we get the answer of c1 is equal to negative 5, c2 is equal to 6, and c3 is equal to negative 3. Therefore, we replace all of this in the equation. Therefore, the position function is 1 over 2t cubed minus 5i plus negative 4e to the power of negative t minus 3t plus 6j plus t to the power of 4 minus 3t minus 3k.
せーのでもそんなんじゃダメもうそんなんじゃほら心は進化するよもっともっと
From the project we have done, the key concept we are used is motion problem. Motion problem consists of two problems, which is acceleration and velocity. From this, we can say that the velocity and acceleration depend each other to build the key concept. In this project, we are using integration method to calculate the acceleration and velocity. From the example we have done, the result shows we can know about the velocity object when we are using integration to solve it. Overall, we can conclude that there is a connection between integration of acceleration and velocity and make a prediction about the object will have motion when it shows the change of the position and time.